that we discovered last time. I've just kind of consolidated them all into one place for you. So they are all on that sheet. If you notice on the reverse side is the unit circle once again. If you've lost your old unit circle, this one's a slight improvement because if you look at the bottom, it gives you the intervals for the inverse trig functions down there as well, which is nice to have in the same place. All right. So what I want to do is I want to pick up kind of where we had left off, and then we're going to do some of the homework today in class after we finish a couple of examples here. Okay. So, yeah, Nick. I don't want to do that right this second. I need you guys to stop talking, though, please. Thank you. So what we're going to be looking at here in Chapter 5, the goal was we wanted to develop or wanted to be able to solve some more challenging trigonometric equation problems, right? Our step to doing that, though, is we have to learn how to kind of manipulate these trig functions when used in combination of one another. So that's really what we're going to be doing for the next two classes, kind of talking about how we can use these identities to, rearrange these trig expressions with the goal of we want to get to solving. So what you're looking at here is kind of a standard Chapter 5 problem. It says simplify the expression sine cubed x plus sine x times cosine squared x. To do this kind of a problem, we're going to be drawing from one of two tools. You can do algebra things, so like factoring or foiling or making a common denominator, combining like terms, stuff like that. Or you can use things from your identity sheet. So if you have your identity sheet right in front of you, the thing I just passed out, my suggestion to you is to have that open while we're doing this so you have something to look at. So you want the identity side up with the list of identities. You don't want to be looking at the unit circle. So when we say simplify the expression, right now this is written as the addition of two terms, right? I have the sine cubed x, and then I have the sine x cosine squared x. Those are my two terms, right? What would be simpler than two terms is one term. What's simpler than one term is something with only one factor in the term. And what's simpler than just one factor is like something with no exponent, right? So ideally, we'd want to get this down to like a single trig function. That would be the simplest you could possibly do. Once you've gotten that far, you should be confident that you're done. But these problems that we're going to be doing don't have like a set, like this is the way you do it and you can do it the same way every single time. They're not going to be, there's only one way to do this problem. So it's what we need to do right now is we need to spend a little time kind of developing some intuition as to about like what are good things to do, what are bad things to do. So I'm going to do a couple of examples here. We'll kind of talk through what we're doing, and then we're going to do something together as a class to work on some of this next set of homework, doing these kind of skills, where you're going to get some immediate feedback from me while we're making suggestions of things to do. Okay with that plan? So when I look at a fresh problem like this, usually the first thing I'm going to do is look for any kind of algebra thing to do. So if I look at this, the algebra things I'm thinking of are factoring, foiling, combining like terms, making a common denominator, stuff like that, reducing a fraction. If I look at this, do you guys see anything like that that we can do? Well, you can't, because one is sine cubed and the other is sine, and one is sine cubed by itself and the other is sine x, but it's being multiplied by cosine, right? So even if it was sine x plus sine x times cosine squared x, you still couldn't combine the signs there. Does that feel okay?
Yeah.
Joey?
Well, we divide cosine squared x.
You want to divide it?
Oh, no, right, no.
Right, because there's not two sides of an equation where you can do something to both sides, but I think you're on the right track. What are those actions, algebraic actions, is kind of like dividing. We said factoring, foiling, combining like terms, common denominator, reducing fractions. Well, you can't set it, it's not something to set equal to 0, right? That's like a solving thing. So the thing that's kind of like dividing is factoring, right? Because what factoring is doing is it's changing it from an addition and subtraction problem into a multiplication problem. And in doing that, typically we're doing some dividing to kind of divide the factors out. So if I look at this, there's two types of factoring you guys have talked about in Algebra 2. You've talked about greatest common factors, which have gone all the way back into like pre-algebra, and then like quadratic factoring. If I look at this, which type of factoring do you suppose we can do? Does it look quadratic? No. So it's probably a greatest common factor, right? So if I look at x cubed, or sine x cubed, or sine cubed x, sine cubed x, and then sine x times cosine squared x, is there a factor in common? Well, x is not, that's not really what x isn't really a thing here. Like you have sine x. Sine is like an operation. So what you mean is sine x that's in common. That is like one thing. AJ, that's what you were going to say?
You can take out sine.
Yeah, very good. So we'll take a sine x out to the front. When I factor that sine x out of sine cubed x, what does sine cubed x become? Sine squared x. Very good, Nick. And what does sine x plus cosine squared x become? When I factor off the sine x. Just cosine squared x. Is everybody okay there? Notice that if you wanted to check that you've done this correctly, if you distribute the sign back through, you should get exactly what we started with, right? And you guys should be able to see that without having to write anything down, right? You can see that in your head. All right. So there's an algebra thing we can do. And this is better because now we've gone from an addition and subtraction problem into a multiplication problem, right? Does everybody see that? So now that I've done my algebra thing, usually now I'm going to look for an identity thing. So I'm going to look at my identity sheet and look for something that might apply in this situation. So go ahead and look at your identities. Give you a minute to think. AJ's found it already. What do you think?
Is it what's the first Pythagorean?
Great. So if you guys look at the first Pythagorean, we called it P1 on the sheet. It says sine squared plus cosine squared is equal to 1. So what I can do is I can replace all of this with just 1. So far, so good. And sine x times 1 is just Yep. And can't do better than a single trig function, so he'd be done. Doing okay still? Let's do a couple more. So let's look at this next example. Again, first thing we typically look for is algebra. Yeah, so Joey's looking at that numerator, and that probably is screaming to most of us like, hey, multiply me out, FOIL that out, right? You have the two sets of parentheses next to each other. That sounds like a good plan to me. What is that going to FOIL out to if we do that? Should be that. Mr. Kulik, how did you do that so quickly in your head? So to me, it looked like that difference of two squares factoring pattern from Algebra 2. Right, do you see that now? Remember factoring difference of two squares last year in Algebra 2? Like x squared minus 4 factors x minus 2x plus 2. I'm using that same idea just in reverse to multiply it out. So I have like an a minus b times an a plus b. I should have an a squared minus b squared. Now, if you don't see that right away, is there any harm in foiling? No. Is it going to take you a couple extra minutes to write it down and like simplify stuff out and combine like terms and all that jazz? Yeah, but it's not a big deal. So far, so good. Okay. All right. What next? What would we like to do next? Yeah, let's look for an identity. Absolutely. What identity looks like a good one to use here? Everybody take a look at your identity sheet. Look through what we have. Edu. Sure. Billy? Okay, so you could use R4 here to say that sine squared, you probably mean R1 though, right? To say that sine squared is 1 over cosecant squared, because we don't have a cosecant anywhere in there for R4. You could, I wouldn't. It wouldn't be wrong to do that, but I don't think it's going to be helpful in getting us to where we want to go. There are better options there, but it's not incorrect. I want to be clear. And that's what makes this a little bit challenging, is oftentimes there's stuff you can do, but it's just not going to be helpful in kind of getting to the end. Or maybe you're going to take the scenic route to the end, which is fine. I will not grade you down for like taking more steps than necessary. But ideally, all of us want to like get comfortable seeing the most efficient way to do these things. So so that's my feedback on that one. Not that it was wrong. I just don't think it's an expedient choice here to getting to the end. What else is possible? So I'll give you a tip here. When I look at the numerator and I see something squared and then also a 1, I start looking at the Pythagoreans. Because all of those involve a 1 and then things squared. I'm going to see if there's a Pythagorean that might cover that numerator. What do you guys see if you look there? Yeah, P3. Right? So what does P3 say? It says that secant squared is equal to tan squared plus 1. So I'm going to take the secant squared and I'll replace it with tan squared plus 1. And now at first glance, you might say, Mr. Kulik, doesn't that make it worse? Now I have 3 things added together on the numerator instead of just 2 things? Well, if you look carefully, there's a nice algebra thing now to do, right? What can we do? Yeah, plus 1 and minus 1 just cancel each other out. So that's lovely. So that's an improvement now, right? We're down to a single thing over a single thing, right? That's better than with addition and subtraction, so that's an improvement. We're getting closer to the end. Now we'd still like this down to a single thing though, right? We don't want to have a fraction if we don't have to have a fraction. So is there any algebraic thing I can do in this situation? Not really, right? Can you factor this? No, there's no addition and subtraction. Can I FOIL this? Well, there's nothing really being multiplied together. I mean, if you really wanted to, you could be like, oh, I'm going to think about this as like tan x over sine x, and then the whole thing squared. But like, it's not really helping us get anywhere. You could do it. I don't think it's going to help, but that's like the extent of what I could do here. So if there's nothing algebraic to do, what should we look for? Identities. So let's take a look at our identities and see if there's anything I can use on tan or on sine that involves the other one, right? So what I'm looking for is an identity for tangent that might have a sine in it, or an identity for sine that might have a tangent in it. Because I'm hoping that those 2 things might cancel out somehow. Good. So Joey's looking at Q1. And there's 2 versions of Q1, right? One of them says tangent is sine over cosine. The other says it's secant over cosecant. Which one would be the one we're interested in? The first one, because we have a sine in our problem already. We want the tangent identity with the sine in it. So notice that our identity for Q3 says tangent is equal to sine over cosine. We have tan squared. Is that a problem? No, right? So tan squared is just going to be sine squared over cosine squared. Like tan to the n would be sine to the n over cosine to the n. Like, and you can do that for all the reciprocal and quotient identities. Okay. Now, do you guys see anything to do? I'm going to draw that big thick bar there so you can tell where the fractions are. Yeah, so if you think about this as a fraction, you can cancel the numerator on the top with the numerator on the bottom. When we reduce a fraction like that, what does it become? 1. So on top we have 1 over sine, or 1 over cosine squared, and on bottom we just have 1 over 1. So that's just going to simplify down to 1 over cosine squared, right? Is everybody okay with how we did that? The other thing, the way I often like to think about this is when I see something where I'm going to use a quotient identity. Before I do that, I kind of think about it this way. So when I do that quotient identity, it looks a little bit more like a multiplication problem rather than a division problem, because sometimes that's a little bit cumbersome to work with. I don't like fractions if I don't have to work with like a fraction side of a fraction. I kind of prefer not to have to think about it that way because it's easy to make a mistake. So oftentimes I'll do something sneaky like that. It's the same thing. We're ending at the same spot. Will. Sure. So far, so good. AJ.
Can you make that into R5?
Yeah, so now using R5, we can call that replacing 1 over cosine to secant, and since it's 1 over cosine squared, that would just become secant squared. And we're down to a single thing. That's as good as we can hope to do. Joe.
So if we got sine squared x over cosine squared over sine, how do you get all that?
So this is Q1. So everything else just kind of copied over, right? So this sine squared is that sine squared. And I can always put something like on top of 1, right? Does that feel okay?
Yeah.
And again, that's why I kind of prefer going this route. Is it's just a little bit clearer to me, like where the fractions are and like what's dividing what. I get a little less lost in the sauce that way. But they're doing the exact same thing. It's just how you want to write it. All right, what do you guys think? Just coming along? We're going to do one more, and then you guys are going to start doing some for me. Yes, go ahead.
Find something on here that's in the problem, and just keep going from there.
Until you get it down to like as far as you can go. Yep. Now there's algebra also. You can do algebra things also. I want to be clear about that. All right. This will be the last example before you guys start doing some for me. What do we see here? So Joey says we can do this. Is that correct? Emily, you're shaking your head no. Why do you think no? Yeah. Well, I mean, we did that right over here, didn't we? But Joey's wrong. We can't do it here. What's the difference, Jacob? Yeah, you can only do this thing if it's multiplication in between. Since this is subtraction, we cannot do that here. Very common mistake. Why I let that play out a little bit. This is the point of what we're doing, though, right? I want to get you guys feedback on this. I want to build some intuition about like what to look for and what to be careful about. Because this is the first time we're doing these things, right? And there's not a set, like, always do it the same way where I can just show you some examples and just like do what I did. These aren't that kind of problem. Have to use a little bit of like creativity and think ahead a little bit. So we can't just cross out the cosines. What else could we do? Yeah, I think that's the natural thing to do. We have two fractions. They're being added or subtracted. I know to add or subtract fractions, I need a common denominator. So let's start by making a common denominator. What would the common denominator be between 1 minus sine x and cosine x? Very good. Yeah, 1 minus sine x times cosine x. How did you know that, Nathan?
Well, I multiply them, and normally you just multiply the two numbers and come up with the denominator, so like I multiply them.
Yeah. So that's good. So yeah, those two denominators are relatively prime. That means that they don't have any factor in common. So the least common denominator would just be the product of the two. It'd be the same thing as if you're doing like 1/2 minus 1/3. The common denominator is going to be 6, 2 times 3, because there's nothing in common between them. So that's us making the common denominators, right? And everybody okay with how I did that? So cosine times cosine is cosine squared. And then I'm going to distribute the sine into the 1 minus sine. But I'm not going to multiply out the denominator. When I'm doing a problem like this, I'm never going to multiply out the denominator, because my hope is later on I'm going to be able to reduce this fraction. For me to reduce the fraction, it must be in like factored form, which the denominator already is. So we're never going to multiply the denominator out. That'll always just stay something times something. The numerator, though, we have to multiply out to combine like terms and then hope to factor again. Is everybody okay with how we've gotten to here? And the decisions that I've made along the way simplifying. Luca.
Why did you multiply by 1 minus sine x for the sine x over cosine x? Like, why did you multiply? Like, I know you're trying to find common denominator. Why did you choose 1 minus sine?
It's the denominator of the other fraction, right? So if I have 1/2 minus 1/3, the common denominator is just like 2 times 3, just the product of the two denominators.
Okay.
Is that?
Yeah.
Okay. That's fine. Yeah. Ask if you're not sure. We can talk through it for sure. Joy.
You multiply the top and the bottom
Correct.
by cosine minus 1 minus sine x.
Yes. So we multiplied this one by cosine because the other fraction had a cosine in it. We multiplied this one by 1 minus sine x because the other fraction had the 1 minus sine x in the denominator. And by doing that, now both denominators are the same, right? Because I've added to one what was missing from the other. Does that look good so far? Okay. All right, let's take a look at what we have now. Cosine squared x minus sine x plus sine squared x all over cosine x times 1 minus sine x. What can we do here?
You factor cosine x from the top and the bottom. Because it's cosine squared x, and cosine x at the bottom. So I put take one and that goes out.
The problem is that the numerator is in factored form. So I can't reduce the numerator and denominator, things from the numerator with things from the denominator until the numerator is like in a factored form. Right now it's 3 things being added or subtracted from each other. AJ.
You can take out a negative sine x
From what?
from both the numerator and denominator.
Well, Nope. Again, the numerator, not in factored form, and I can't reduce out a sine x because I don't have a sine x in the denominator. I have a 1 minus sine x.
Oh, you thinking that is just one?
Yes. Yeah, you would think about that as like a single thing, like one thing. Let me give you a hint. It's identity time, folks. Take a look at your identities. There's a good one here. Age.
Is it O equal
Nope.
negative sign?
No, so if I look at what I have and all of the insides are the same, like they're all x, for example, I would never use an odd even, and I would never use like a cofunction. Those ones I'm going to use to make the inside x for everything so I can reduce and combine things. But if everything is all the insides are the same, I'm not touching any of the cofunctions or any of the odd evens. Emily. Yeah. So sine squared plus cosine squared is equal to 1, but I don't have sine squared next to cosine squared. Yeah, it's all being added, so right, like you can do that, you can put the sine squared wherever you want. Yeah. So we can take those two, and that can just become 1. Yeah, we can reduce our fraction now. Yes. And which one was that? That was like R2? 2 or 5? 2? Okay. Are we sure it's 2? Nope, it was 5. Okay. We feeling like we're making a little bit of progress here, developing some intuition. It's now time to do the homework as a class. So what I've done is I've divided you guys up into 8 groups of 2. So feel free to get up, move around, sit next to the person you're in a group with. These were randomly created. There was no
You manifested that.
no, the random seed generator that I built. Yeah. So this is the computer program I wrote to do this, if you're interested. This is not. So you guys should move next to your partner. I mean, we're going to be doing the homework, so I would write this all down somewhere so that you have the homework done. But so your next homework assignment is going to be 7 through 14. That's what we're going to be doing right now. So as we do these things, I would encourage you to write it down so that when, hopefully by the time we finish today, the homework is going to be done, and you're going to be all set. So the way this is going to work, I'm just going to call one group at a time. I'm going to ask, like, what should we do next? Algebra, identity, and then, okay, after you've picked which one you want to do, what would we do? And I'll give you feedback as to whether that's a good idea or bad idea, and why or why not. It's going to be basically, sure. We're basically going to be doing the same thing we just did with the examples, except now you're going to have to answer something, right? So when we do it, and I don't call on anybody specifically, we allow like 2 or 3 of us to like carry all the weight. But now everybody's going to have, with a partner, have to think about it and come up with some kind of an answer, right? My suggestion to you is, as we're doing this, if it's not your turn, be thinking this and think about answering the same thing I'm answering, right? We're just going to do one group gets one step, not one question. So we're just going to keep going around in a circle until we've done everything we have time to do today. Maybe the whole thing, maybe not. Everybody's okay? All right. So group 1 is all in the bathroom right now, apparently. So group 2, we'll start with you guys.
Nate's in the bathroom.
All right. Group 3 then, we'll start with you. So Nick and Luca, we have cotangent u times sine u. Algebra or identity? What do you see to do algebraically? Again, think about your algebra things you'd have are like factoring, foiling, reducing fractions, making common denominator, combining like terms.
Oh, there's nothing we can do algebraically, so do we just look on the cheat sheet?
Absolutely, yes. So Lucas said, okay, you just listed all the things that we can do algebraically, and there's nothing I can do with this, so I'm going to go to an identity instead. That's a good decision. So what identity do you think we should be looking for? Still you guys. The first person's always has the hardest time with this because it's haven't had a chance to look at the identities and think about where the problem is going. So when you have to start it, it's always the hardest one. So here's what I would say to you. If I look at this and I have cotangent to the first times sine to the first, right? So the places I'm looking is exclusively going to be at the reciprocal and quotient identities because I don't want to change the variable and I don't have any squareds. So I'm strictly going to be looking at those first, 14 of them or whatever there. Good. Which version of that? Do you want to write cotangent as cosine over sine or cosecant over secant?
Cosine.
I agree. Why did you pick that one? Because you already have a sine in the problem, right? Okay, group 4. You guys are AJ and Hunter. What are we going to do next? Great. And what can we say then? So we're done, right? Hey, we did one.
I don't understand how this is a cosine u. Oh, you crossed them. Oh,
I love it when we ask a question, we answer our own before I even have a chance to open my mouth. Makes me feel good, right? Oh no, somebody's late for something.
The time sign over 1.
How come I didn't times?
You did multiply sign over 1.
Well, I didn't. It's part of the problem, right?
Oh,
I just took that part of the problem and wrote it over 1, so it was like fraction times fraction. I wasn't going to be confused about multiplying fractions,
okay.
right?
Yeah, okay.
So I just rewrote that part as a fraction. All right. Let's see who we on. Joey and Alondra. We're going to be looking at number 8 here. Identity or algebra. Make that a little bigger or something. What algebra would you want to do? So a trig function is not distributive. In fact, the only things that you know that distribute are multiplication and division, right? Remember, tan isn't a number. It's not something they can distribute. It's an operation. So you can't distribute that. You can reduce this fraction. That's correct. Since everything is being multiplied, we can reduce a cosecant from the numerator with a cosecant from the denominator. That's a good thing to do. Everybody feel okay with what we did there? Okay, who's next? We're not done, but you guys are done. Billy and Allie. Yeah, what identity do you think?
Can you use C6?
Great. Yeah, that's exactly what you'd want to do. So they're saying to use one of the cofunction identities because, as we mentioned before, the insides of our two trig functions are not the same, right? One is pi over 2 minus x, the other is just x. In order to do any reducing later on, we have to make those the same. So I'm going to be looking at the cofunction identity, C6, that allows me to replace that tangent pi over 2 minus x with just cotangent x. AJ, what's up?
How do you cross out the square?
Well, it's really like down here, it's like cosecant times cosecant, right? That's the same as cosecant squared.
Oh,
So you can reduce one of them. Either way, the thinking about it is fine. I usually just think about like reducing the exponent because it's just less writing to me, but it means the same thing, right? Does that feel okay? Everybody else okay with what we did there? All right, let's see. Who's next? Jacob and Lucas. Yeah, great. So they're going to use the identity Q2. And the reason they want to do that is they're going to rewrite the cotangent as what? Yeah, you want to do cosecant x over secant x. And I'm going to write it this way. Is everybody okay? We've talked about when I have like a fraction like that, oftentimes wanting to rewrite it that way. Helpful? We're okay? Will and Emily, I think you guys are next, right? What are you thinking here? Absolutely you can. Yeah, we can just reduce the fraction. And what are we left with then?
1 over.
Great. And back up to group 1, Billy and Peyton, right? What are we thinking here? You guys are supposed to be sitting next to each other.
I didn't even see you. I'm so sorry.
It's okay. Let's wait for these guys and then I'll get back to you, okay? I promise. I just want to get... What do we think here? What's up?
I think not.
Okay, so you just need to be looking at your identity sheet from right now. Okay, so just look at your identities. Because at this point, there's no algebra to do, right?
Can I get like a hint on what I'm looking for, maybe?
Yeah, so if I look
Start there.
if I look at this, I see everything is to the first power, and there's no addition and subtraction.
Yeah.
So I'm going to be looking at just the reciprocal or quotient identities. Okay? Now, secant is not the start of any of the quotient identities, right? Those start either tan equals or cotangent equals, so those are out.
Yep.
So then I'm going to look at the reciprocals.
Okay.
So that's 6 of them. See if you can pick the one that you need from those 6.
Is it the secant equals, or is it the one that's 1 over secant?
Well, if you look at your reciprocal identities, do you have all of 1 over secant as a reciprocal identity?
Put in R2.
That's the one I would be using then. So I would use R2 to rewrite 1 over secant as cosine, and you'd be done, right? Joey.
So if you write, like how you want cotangent x over cosecant x, you write it like cosecant x over secant x over cosecant x
Over 1,
over it's over
right? Because cosecant, I want to write the bottom as a fraction.
Wait, because if I still want to simplify that, I get like secant x over 1.
So you end up with like 1 over secant x over 1 over 1. So you end up with the same thing, right? You're good? Okay. I'm going to erase that real quick because I'm going to run out of space. All right. All right. Number 9. Khalil and Edu, I think you guys are next. Algebra or identity here?
Let's think for a second. 1 minus, well, I'm saying identity
Good.
because you can't what's it called, factor anything out really. There's no real algebra to do, I see. So I'm going with identity. So I'm looking for something that there's no 1 minus cosine squared that I'm seeing. So I'm probably going to say I can look for something with sine x.
Well, there's an identity that involves a 1 and a cosine squared.
Oh, right here. Sine squared plus cosine squared
Equals.
equals 1.
So how am I going to use that?
Sine squared.
I'm going to replace the 1 with sine squared plus cosine squared. And now, Mr. Kulik, doesn't that just make it worse? Because you're making it longer? Yeah, but for just a second. Yeah, so now the cosine squareds can cancel. Absolutely. And now you guys are doing too much, but that's okay. You guys are on, if you see it, you see it, right? All right, who's the next group after these guys? Let me look here. Nick and Luca. Yeah, sine squared x over sine x.
just cancel out like points.
So you reduce, absolutely, yep. And what are we left with?
Can you explain how you got like the subtraction?
So I used P1 to replace the 1 with sine squared plus cosine squared.
And then just one like I got.
So that's a frequent when you have like 1 minus something squared. Pythagorean is what you should be thinking about. If it's a sine or a cosine, you want to replace the 1 with the sine squared minus or plus cosine squared. And then you'll just have one thing left, which is better than two things. All right, let's see who's next. AJ and Hunter, number 10. I think this is the sneakiest one. Algebra identity, what are we thinking? AJ and Hunter, what are you guys thinking? Identity. Okay. I wouldn't yet. I think there's some good algebra stuff that will make this go much quicker. Let them struggle. We'll get to you. You guys will get your chance. So that's a good idea. It's not the best idea we can do here, though. There's a better algebra decision that you can make here. Although that is, I would say, the 95% of us, if I told you to do an algebra thing here, would think to do that. Because it screams make a common denominator. But there's something better than that to do even in this particular problem. What do you notice about the numerators? They're the same. What can we do with that? No, you can't do that. But the numerator, if the numerator is the same, that makes it a common factor. So the best option here from an algebra standpoint is to factor off the tan x. Now that's a tough pull for the first time through. I want to tell you though, if you make a common denominator, you can get to the end. It's going to be messier than it needs to be though. Is that okay? Now that was the hardest. I think this is the hardest one in seeing like the best way to do it because of that piece. All right. Let's see who's next. Okay, Joey and Alondra. Algebra identity here. What are you thinking you're going to do algebraically? Okay, so you could do that here. There's a better option, though. Okay, that's not incorrect. I would do identities here. to turn tangent into something over something?
Yeah.
I would pass on that. I don't think I would do that here. I wouldn't want to change like a denominator without addition and subtraction into a denominator with addition and subtraction. That's usually going in the wrong direction.
I don't really know which one to choose.
So when I look at 1 over cosecant squared plus 1 over secant squared, if I'm not going to make a common denominator, which I told you is okay to do, but there's an easier route. Yeah, so I would use the reciprocals. I would use R4 and then, R1 and R2
Yeah, I want
to change that. So that's going to, R1 allows us to rewrite 1 over cosecant squared as sine squared. And R2 allows us to rewrite 1 over secant squared as cosine squared. Allie and Billy, you guys are next, right?
Do we distribute the tangent next, or do we still need to take a bonus step?
You could distribute the tangent. I would not.
So back to IPC.
Yeah. There's a good one. Should be staring you right in the face.
Oh, yes, that's P1.
Mm-hmm. Yeah, sine squared plus cosine squared we know is 1. And look at that. We managed to do this whole problem without ever having to make a common denominator. Right? Which again, you could have done. You would have gotten to the same spot. It's a lot messier. Right? You have to end up using more identities. It's going to take more algebra steps. That's a nice, neat route that we just took through there. Although to see it right away is hard. It's not obvious, the route that we took through that, although it's very nice and compact. So far, so good? All right. On to 11. Is it Lucas and Jacob? Are you guys the next ones in line? Okay. Yeah, absolutely. So Lucas and Jacob say they want to do P1 because they see a sine squared plus cosine squared. Now I forget who comes after you guys. Will and Emily. Excellent. Yeah. So P3 allows us to replace the 1 plus tan squared with secant squared. And then we're back up to the top now, right? Peyton and Billy, what do you guys think? We have secant squared over secant. Algebra or identity? Yeah, it's okay.
What'd you say before?
Algebra identity.
Oh, algebra.
Okay, I agree.
Let's go. It's all about confidence.
Well, you gotta solve it
It's
now.
all about confidence, baby.
What can we do? What algebraic thing are we going to do?
Don't let Peyton take from here.
Well, you have a fraction, right? Shh. We have a fraction, right? We have secant squared over secant. What are the algebraic things we can do with a fraction?
Would you say something? Take out one of the secants.
Yeah, we can reduce, right?
I was just trying to help you to answer the question.
Yeah, I told you that
I was supposed to get there. I thought you held it out for me.
So reduce the fraction. Secant from the top cancels the secant on the bottom. We're left with just one secant on top. That's it. We're done zoned. How are we feeling on these? Is this starting to build some intuition about like things you can do and not do and how to look for what to do next? I know this is hard at the start because you don't have any intuition. This is how we get it though, right? We have to try to do things. You have to give me ideas of what you're thinking. I'm going to shoot them down and you're going to, okay, this is not the time to do that. Or I'll be like, okay, that's a good thing to do, but there's still something better. And you'll start learning to look for the little tricks that Mr. Kulik is going to point out to you along the way. But we just have to do this, you know, like where you give ideas and I give you feedback on your ideas. It's just kind of how this has to work. I think Nick and Luca, you guys are up for 12, right? Are you guys the second? No, you're not second in line. Yeah, Edu and Khalil.
number 12.
Yeah, 12.
Identity.
Okay, great.
Wait, yeah. C5, co-function identities.
I don't think I would use a co-function here.
Oh, wait, that's never mind.
Okay. Doesn't matter.
Oh, R5.
Well, why not just do like R5, for example? So let's write it that way. Notice the negatives are still in there. I haven't taken care of those. Oh, shoot. Yeah, no wonder you're looking at me funny.
I was gonna say.
Yep. There we go.
So it's cos is just like cosine, negative x, 1.
Yeah. Now, could you have used the odd evens there to make those x's positive? Sure. Did we need to do it though, since they were both negative? We did not. If you had one positive and one negative, would you have needed to do it then? Yes. Because they would not reduce if the stuff inside is not the same. But because the insides were the same, you did not need to use an odd even identity there. You could get away without doing it. Can you do the odd even identity? Sure. Is it fine to do? Sure. Is it a step you don't need to do? Yes. Is it wrong to do it? No. But we're interested in trying to do this the most efficient way possible, right? You don't want to take 10 steps to do the problem when you only need 3, kind of thing. Sure, kind of like playing chess, right? If the end game is 3 moves, don't take 10 moves to get to there, right? All right. Now it's Nick and Luca with 13 here. What are we thinking there? Great. So that is cofunction 1, right?
Yeah.
Okay. Who comes after these guys? Is it Hunter and AJ? Is that right? You guys next in the line? I thought so. If I'm wrong, say something. Okay, that's what I thought too. I just didn't want to scroll back up because I'm just getting sick of making myself car sick. What are you guys thinking here? Algebra identity, what are we thinking here? Okay, which identity do you want to use? Nothing is squared, so P1's not going to be helpful here. You can't use any of the Pythagoreans without squareds on things. Okay, so we can add sine alpha with sine alpha, but you don't get sine squared alpha. So think about it this way. If I add like y plus y, what do we get? 2y. If I add z plus z, I get. If I add sine x plus sine x, I get 2 sine x. Yeah. So you can do that. That's just an algebra thing. You didn't need to do that here, but we can. Right? At some point, we're going to have to do it. We can do it now. That's okay. All right. Next is Joey and Alondra, right? Yeah, it's identity town. We've done all the algebra we can do here. Yeah. What are we going to rewrite tangent as?
Side.
Yeah, sine over cosine, right? I'm just going to leave the subtraction symbol in front. I'm not going to mess any more with it than that. Since everything is just being multiplied, it's fine. You know what I'm saying? But I think you guys are next.
Okay, so, we'll cross out the cosine.
Great. Yep, we can reduce those.
So we get sine x.
Yep, and then we can combine the like terms. So 2 sine alpha minus sine alpha is just sine alpha. And we're done. For the record, I would have at this step used Q1, and then I would have had sine minus sine plus sine, and that's when I would have combined my sines, rather than doing it 2 separate times. Right, because the way you guys did it, we did it once here, and then we did it a second time there. If you just ignored all the combining of sines until the very end, you would have only had to do it once instead of twice and saved a step, but like, I don't think that's much too big of a deal. All right. Is it? You guys, Lucas and Jacob? We're on to 14 now. This is the last one. That's exciting. What do you got? What's up? Nope. That's not how we can reduce fractions or how we add fractions. There's not a factor of sine y anyone in here because you have 1 minus sine y and 1 plus sine y. So that you have to think about as like one thing. Like 1 minus sine and 1 plus sine are different things because they're both just like one thing. You're right to look for an algebra thing though, which is what it sounds like you're doing. That is what you want to be doing here first. If you have 2 fractions that are being added, okay, to add them you need to have that's what we're going to do first, is make a common denominator. What would the common denominator here be? Or do we have to multiply the top and bottom? Yeah, but you mean them in this order, right? So our new numerator is going to be 1 times 1 plus sine y plus 1 times 1 minus sine y. And remember what I've told you guys, that when we multiply 2 fractions, we're never going to multiply the denominator out because the hope is at some point to do some reducing and get away with not having to do that. If we have to multiply it out later, we will, but like we should start by not assuming, by hoping that we'll just be able to reduce things away. I think we're back to the beginning now. Is that right? Billy and Peyton? What are you guys thinking here? We just made a common denominator, and we're left with this fraction now. What? What do you mean by reduce? Okay. So what do you, can you be a little bit more specific? Like the direction for this whole problem is simplifying, right? Like, help me out with like what it is that you're talking about canceling out, or just so if you're struggling with the vocab.
Can't you add?
Yes?
Yeah, you can like add the 2 equations.
Yeah, you can do 1 plus 1 and sine y plus negative sine y, right? So those guys add to give you 0. We have a 2 on top, I'm then going to FOIL out the denominator. I'm going to use P1. Cancel or combine the like terms there. I'm left with 2 over cosine squared, which turns into 2 secant squared using, what is that, R5. And there I'm done. Congratulations, we finished the entire homework assignment here together in class. Great job. Hopefully we feel a little bit better about like this process and kind of how to navigate that. We're going to do this again later this week.